Okay, like Lynn mentioned last video, thermochemistry is all about the chemistry that involves heat in it. So there's three different ways that we can transfer heat. Remember, we're not creating it or destroying the heat or the energy, but we can move it. And these are three different ways to move it. So the first way is through conduction. Conduction is between objects by direct contact. That's a big deal. Conduction, direct contact. What that means is they must be touching each other. Nope, there's right there written right. Awesome. Next part, convection. That's through a fluid. Convection is only through fluids. Remember, air is technically a fluid. If you don't believe me, look at how airplanes fly. They're actually flying on the liquid in the air, not necessarily the air itself. That's called by circulation or movement of molecule. If you think of a convection oven, some of you have these at home. If you look at the back of your oven, you're going to see a fan back there. That fan is circulating the air, which is a fluid, so that's why it's called a convection oven. Now, the bottom, radiation. Now, radiation comes through waves. That's why we call it electromagnetic radiation. The big thing you got to know about this is it can travel through a vacuum. That should make sense because space, more specifically outer space, is a vacuum. That's how the Earth gets heated, through that radiation from the sun. So look at our picture down here at the bottom. This hand is touching the pot. So the heat's going to go from the pot to the hand through direct contact. So that's conduction. The fluid is being circulated right here. If you look at those dots or those bubbles inside of a boiling pot of water, they're going up and down. They're circulating right around here. They're circulating through the water, through the fluids. That's going to be convection. And the fire, anytime you see fire, it's going to be radiation. So let's go through and classify these. Must have direct contact. That's going to be conduction. Travels as waves. This will be radiation. Only through fluids, it's convection. Those are your base definitions for each one of those three. Matter must be present. Remember, conduction must be direct contact, so that would be matter. Convection is through a fluid, so matter has to be present for it to be a fluid. But radiation can go through a vacuum, which means matter does not have to be present. Which leads us to our next question, the vacuum. That's going to be radiation. Heat from the sun, that's going to go through a vacuum, so that's radiation. Then from hot water to cold water. Well, water is a liquid, so it must be convection. And heat from your hand to a piece of ice, or assuming the ice is touching your hand, so that will be conduction. So it's all pretty simple if you just know those three base definitions. Moving on, units of heat energy. We're going to get to this in a little bit. But we always measure energy based on joules and calories. And you got to know the definition of a calorie. It's the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. Know that definition because there's another one that looks very similar to it coming up. And this number right here, 4.184 joules, is going to be a number that you're going to have to memorize. It is on your formula chart, so it's going to be good to know. So you see this next part down here, 1 little C calorie equals 4.184 joules. That's going to be a conversion factor that you're going to need to know. And finally, this last thing down here is very important. 1 lowercase c calorie equals, or 1,000 lower c calories equals 1 big C calorie. You've got to look at the capitalization of there because they mean different values. And then 1 big C calorie is 1 kilo small c calorie. Now that conversion, pay real close attention to the capitalization. It does matter. It'll throw your answers off if you're not careful with it.